Okay, valid. Basically today, we're just gonna show, we're first gonna show like how to model basic relationships in SQLite, and then we'll move to like the VS Code. So first, you should have installed SQLite 3 last time from demo 2. So I'm just gonna open terminal. And then to activate SQLite 3, we're just gonna do wait, let me make this bigger, sorry. Is that a good size for everyone? Where is it? Okay, cool. So to activate it, we just wanna type in SQLite 3, and then you should be met with this like command line interface for SQLite 3. Cool, so this should have been downloaded last time, but if you have any issues, feel free to raise your hand. But what we're first going to do is just create a table for users and NAT IDs, and we're going to create the one-to-one relationship that we talked about in lecture. So if you don't remember, to create a table, we basically want to do create table, and then we're just going to call it users. And then in users, we just want ID, which is the integer primary key, and we're going to auto increment it. And then we also want name, and we don't want this to be null, which is the text. Cool. So this is how you create a table, and then you can check what tables you've been made by just doing, dot tables. So you can see here that we made a users table. Does that make sense to everyone? Cool. So I'm just going to create another one for NAT IDs. And then we want the NAT IDs table to reference the users table so that we can create a relationship between the users and the NAT IDs. And then because this is a one-to-one, your user ID should be unique. So to do this, we're just going to write user ID is integer, and then to represent that it's unique, we do the keyword unique, and then another comma, and then to establish that foreign key, which basically is that column in the users table right here. We want to write user ID, and this references users table and then the field ID. And then we're just going to end this. And then we've created our NAT IDs table. So I'm just going to double check that it's actually been created by doing dot tables. And you can see the NAT IDs table is here. Does that sort of make sense to everyone? This is just a quick review from last time with the addition of the foreign key column for a one-to-one relationship. And the unique is just to establish the only one name can be associated with one NAT ID, and one NAT ID can only be associated with one user. Cool, so I'm just going to insert some values into the table now. So I'm going to insert myself into users. Oh, wait. I forgot to establish the column names. Wait. So basically, I just inserted myself into the users table. And to check that, I can just do select asterisk, which is everything from. I'm a really bad typer. So you can see that I've successfully added myself to the users table, and then I'm just going to add Shingo in the users table as well. So I'm just going to do the same thing, insert into users, column name, and values. Yeah, so I'm just going to double check that I added everything. And you can see now I have two values, key and Shingo in users. Does that sort of make sense, everyone, how I inserted the table, values into the table? Okay, cool. So now I'm just going to add stuff into NetID. And in NetID, you see we have this user ID. So we have to insert the user ID when we insert stuff into the NetIDs table, which will make more sense once I actually do it. So insert into NetIDs, we want to insert the actual NetID and the user ID. And then the values. So I'm just going to insert my NetID in, which is KSL67, and then my user ID, which you can see up here, is 1. So 1. And then now we're going to check if it's successfully been added into the NetIDs. So you can see this is our NetIDs table, and this is the ID for the NetIDs table, and then this is the actual NetID that I added, and this is the foreign key that references the user ID. Does that kind of make sense? So for user ID, I have NetID KSL67. Cool. So I'm going to do the same thing again. Here's Shingo. And then he's user ID 2, and then we're just going to check everything's been added. And cool, now I have two things in my NetIDs table. And then now, let's say I'm like feeling quirky or something, and I want to change my NetID to Gonzalo's NetID, which is GG387. So I'm just going to insert into NetIDs, NetID, user ID. Then I'm going to add another NetID for me, which is GG387 for user 1, which is me. And then you can see that I get an error because when I defined my NetIDs table up here, I said the integer had to be unique. And because I'm inserting another value into NetIDs, for user ID 1, I failed the constraint that every row had a unique user ID. So this is a one-to-one relationship. Only one NetID can be associated with one user and vice versa. So yeah, if I wanted to change this, I would have to do an update command instead of an insert. Does that kind of make sense? Cool. Okay, so this is a one-to-one relationship. So now we're going to do a one-to-many. So I'm just going to skip a couple lines here. And let's say I'm like making a social media app for like Cornell students. And so I want to have posts now. So posts is like a one-to-many because each user can have multiple posts. So I'm going to first create the table for posts. And then let's say we're just going to do description, which is text, not null. And then we want to have this be associated with the user. So this is going to be an integer, and we don't want it to be null. And then we're going to establish that relationship with the users table. So I'm going to do foreign key, and then the user ID is going to reference the users table and then the ID field. So now when I check all my tables, you can see I have 3 tables and a new post one has been created. Cool. And then notice how, because this is a one-to-many, we can have multiple user IDs be associated with multiple posts be associated with a user ID. So this does not have to be unique. It just has to not be null. And then, yeah, I'm going to make a post now. So let's say I made the post. And I'm going to say, I love Max flatbreads. And then my user ID is 1. And then I'm going to select everything I have from post. And you can see that, again, post ID 1 with the description, I love Max flatbreads, is associated with user ID 1. Does that kind of make sense how I did that? Cool. So I'm going to do another insert statement. So let's say Shingo wanted to post something. Let's say he said Kate is the better instructor, because I am. And he is user ID 2. And then if I select all from posts, you can see that now I have 2 posts associated with 2 different users. And I can even like, let's say I wanted to make another post like, really nervous for my prelim tomorrow. And then I'm user ID 1. You can see I did not get an error, and I have multiple, oh wait, that's users, sorry. You can see I have multiple posts associated with user ID 1. So they're not, I mean, the unique constraint for the users and not IDs does not apply for the one-to-many relationship, because we established that the user ID just has to be not null and not unique. Does that kind of make sense? Okay, cool. So yeah, this is a one-to-many, so I can keep on adding rows for my posts associated with the different users. And then one thing I wanted to show was, so we use SQLite in this class, which is just like one interface for implementing SQL. And so the thing about SQLite is that it's not very strict when it comes to like what kind of data you want to insert into your table. So let's say I wanted to insert into posts, and then description, user ID. And then let's say someone said full summer is such a flop. And then this is user 1000. So you can see that no error message was returned, even though a user with an ID 1000 doesn't exist. We only have, or you can see up here, we only have 2 users. So SQLite doesn't really enforce what type of data you insert into each column, which kind of contradicts what we said last class, that this is why databases are good. But this is only with SQLite. With other types of database interfaces like Postgres, the data type is actually enforced. So yeah, just don't insert anything wacky into SQLite, but just wanted to share you all that. And then last thing is you can have like different functions for each column. So for example, I can count how many posts are associated with user ID 1 or user ID 2. So I can do select count from posts where user ID equals 1. So I want to see how many posts I have, and I have 2 posts. So I can do the same thing for Shingo. So he has 1 post. And then because the data type wasn't enforced by SQLite for user ID 1000, you can see user ID 1000 also has 1 post. But if I did like count for user ID 10, which did not have any posts, you can see it's 0. So I can verify this by just selecting everything from posts. Everything is correct. So count is just sort of like another function. You just have count and you insert whatever you want to count, and then from the table. And then the where is something we learned last class, which is just sort of like a conditional statement. Does that kind of make sense? Good question.
So when you're creating the table, what's the point of the foreign key reference? Like it doesn't enforce anything.
Yeah, so the foreign key references still establishes that relationship to the other table. So for example, here we established that this user ID is associated with users. So later when we select like values from the users, so I can do like select users dot name, which is only a field in the users table from users. I can do that because it's sort of related to the post. Does that kind of make sense? So I can get stuff from other tables that I have like a foreign key associated with using this column, but it just doesn't enforce like if something exists in that table or not. Yeah, does that kind of make sense why the foreign key is still relevant? Because we still want that relationship to happen when we're like relating users and posts and stuff like that. Cool. So last type of relationship is the many-to-many. Does anyone have any questions about the one-to-many or the one-to-one? Okay, cool. So I'm going to lastly implement this hashtags feature in my social media database. So this is going to be a many-to-many relationship because many posts can be associated with like many hashtags, and many hashtags can be associated with many posts. So it's sort of like a mutual many relationship thing. So I'm going to create a table called hashtag, and then the values are the ID for the hashtag table, which is an integer primary key, and I'm going to auto increment it. And then I'm going to do post ID. Oh, wait, just kidding. So for the hashtags, I just want the hashtag name, my bad. So we're just going to do hashtags, and then the hashtag is just going to have a name, which is a text. And then we're just going to end that. So when I do .tables, you can see I have another table right here called hashtags. And because this is a many-to-many, I'm going to create that sort of association table that associates the hashtags and the posts together, which is basically what the students in courses join table did in lecture. So this is just going to be another table, and I'm just going to call this like your feed or something when you scroll through a hashtag. And then your feed is also going to have an ID. And then now we're going to sort of have those columns that associate the posts and the hashtags together. So I'm going to have a column called post ID, and this is going to be an integer that's not null. And I'm going to have a hashtag ID, which is also an integer that's not null. And then I'm going to just do like 2 foreign key references because they are foreign keys. So I'm going to do foreign key post ID references, post, and then ID. And then I'm going to do another one, which is foreign key hashtag ID references. And you can see when I do .tables, I have my association table created. So we're just doing the same thing we've been doing for all the other tables, but now the only thing in this association table is just the IDs from the different tables. Does that kind of make sense? Cool. So I'm just going to insert some hashtags in. So let's say I have a hashtag for food, and then we're going to have a hashtag for pool. And then like code or something. Cool. So now if I select everything I have from hashtags, you can see I have all the hashtags. And then I'm going to insert that relationship between the posts and the hashtags now. So insert into feed, and we want to insert a post ID and a hashtag ID. And then let's say for these posts, I want to have hashtag food for this first post right here. So I can do values and then 1, 1. And then when we do select from feed, you can see this is sort of like not very readable, but this is like the feed ID 1. And this is, it's associated with post ID 1, and this is associated with hashtag ID 1. So this is just sort of a bad example because all of them are 1. But if I insert into feeds like post ID, hashtag ID, and let's say I wanted to associate Kate as a better course instructor for hashtag ID 2, where let's do hashtag ID 3, which is code. Let's do select from feed. And then you can see I have like another sort of column or another sort of row for all the joined thing together. So I know this is not very readable, but I can do like a really fancy like join statement that sort of makes this more readable. And this is sort of what I mentioned earlier as why the foreign key is important, because it sort of establishes that relationship with each other. So let's say I wanted to select the users. Well, let's say I just wanted to select the post description and then the hashtag's name from the feed. And I'll talk about the inner join in a minute. On post ID inner join on hashtags. Hashtag ID. I'm going to end this. So you can see this is much more readable, and this is basically everything in here, but I'm taking the posts in the description, which is I love Max flatbread with the hashtag, which is food. And the same thing with Kate is a better course instructor with code. And then the inner join just basically takes all the instances from feed and post where the feed post ID is equal to the post ID. And then we do the same thing with hashtags where we take everything in the feed hashtag column and we query everything from the hashtags ID that matches with it. Does that kind of make sense? So just like a basically like loops through the whole table and it finds where the post ID is equal to the feeds like post ID in here. And then the same thing for hashtags. Does that kind of make sense? So it's sort of a very big statement, but that's sort of what it does. And it makes this more readable. And the reason we don't do this directly is because if we do this multiple times, it's going to be really not legible. And this is just easier on the eye, but it's sort of like referencing objects and their attributes in Java or Python. So yeah, does that kind of make sense? This whole SQL thing and how we have sort of created all the relationships that we talked about in lecture. Okay, cool. So next time we're just going to implement this in like our actual server. But yeah, we're just going to move on to the Kahoot now. What? Okay, hi friends. So we're just gonna get started since it's 8:35 or 8:36 now. But if you're just coming in, make sure you go to the course textbook and then you refresh it and then download the updated demo restarter code from the pre-class to-dos because we made some changes. But yeah, go ahead and do that in the meantime. But today we'll just be continuing the demo for relational databases. Last time we sort of demonstrated how you create relationships between tables in SQLite 3 in the terminal. But today we're going to actually implement all of those concepts in the server in VS Code. So yeah. So before we get started, once you download everything, make sure you first have your virtual environment up. And then make sure to activate your virtual environment. and then install the requirements we need. Okay, cool. So once you have your virtual environment set up, we're actually going to start coding. So here we have our app.py, db.py, requirements txt.py. I mean, not py, just requirements.txt. So this format is basically going to be the same thing. Sorry, it's going to be the same thing as last time. We're just going to be implementing the tasks to do stuff with subtasks, and that's going to be related to our original task table. So in app.py, you can see here we have our success response functions, and basically these are just going to be generalized functions that we can call that will return the format for success or failures that we usually do and the API spec, and it just makes everything easier so that we don't have to type it in every single time. But basically we set code to be 200 default every time if we don't specify a code, because 200 is the most common. And similarly, we do the same thing for the errors with 404s. So yeah, that's basically what that is. And then, yeah, this is all from last time. Here you can get all tasks, create tasks, update tasks, delete tasks. So yeah, this should be all there already. And then in db.py, you have your task table. So yeah, today we're going to be working on creating the subtasks. So I'm just going to start by creating the subtask table. So you can see that we first obviously need to create the subtask table in of itself. So the first function we're going to write is just the create subtask table function. So and make sure this is the right instance. Oh, and if you have any questions throughout this demo, feel free to just raise your hand and one of the TAs or co-instructors will come help you. So in this function, we're going to use SQLite 3 to create the subtask table. And then to actually do that, we're just going to try to first execute the command. So this is what we did in the terminal last time. It's just create table subtasks, and then and then in subtasks, we're going to have an ID integer primary key. We're going to auto increment it, and then we're also going to have a description. And then this is going to be not null. And then because this is a subtask, we want this to have a relationship with our task table up here. So we're going to create a task ID field. And then this task ID, is going to be a foreign key. And then it's going to reference the task table and the ID there. And then we're going to end this with the parentheses and semicolon. And so we're going to try to first create a table, but in the case that we're restarting this server, we don't want to create a new table every time, and it's going to give us an error if we do. So we're just going to catch it. And then it's going to, yeah, that's it for this function. And then one last thing we have to do is, this is all in the class database driver, which we initialize in app.py, which we also did last time. But every time you create a table, you have to add the create table function to the initialize for the database driver, so that whenever you like initialize db in app.py, the table is actually created, or else the subtask table will never be created. So we're going to do self create subtask table. And basically, now we can start this app, and we're not going to run into errors with creating a subtask and like the table doesn't really exist. So what we can do is we can just, we're going to just add another function for creating a subtask. So to do that, we want to insert into the subtask table. So again, we're going to create another function called insert subtasks. And this is going to get basically everything we need. And then this ID here is going to represent the task ID. So I'll just make this a bit more clear. And so basically, we're just going to execute a command that inserts into the subtask table. And then we're inserting into description task ID, and we're doing the values question mark, question mark, question mark, and then semicolon. So if you don't remember, the question marks are basically like variables of some sort that we pass in from the function, because we aren't really sure what the description, done, and task ID are going to be when we're like creating this command, we're doing this command. So we pass it in from the function parameters. And then to actually do it, like pass it into the SQL, we have like the second argument over here that specifies the parameters. And so we just do description on task ID. And it's really important that you do these in order, because the order does matter. Like the description is going to correspond to this first question mark here, and then like done is going to correspond to the second one, and task ID is going to correspond to the third one. So yeah, make sure to keep the order right and everything. And then yeah, so here we just inserted everything, and then we're going to set this equal to the cursor, and then we're going to like commit it to the table so that our changes actually appear, and then we're going to return the ID of the thing we just created. And then again, make sure to write documentation. So here we just use SQLite 3 to create work. Let me make this show everything. Okay, cool. So now we have a function for creating the table and inserting something into the table. But the last thing we need to do before we, I guess, test it is we want to make sure we can actually get the values from our table. So the last function I'm going to create for now is going to be get all subtasks. And so here we're just going to use SQLite 3 to and then this is just going to be select star from. And then we're going to basically create an array that parses through the cursor and then adds everything to our array, and then return the array. So for row and cursor, we're just going to do subtask.append, and then we have our ID is 0. And then we have the description. One. Done, which is 2. And task. And we're going to also, oh, we need to put this all in a dictionary. Here, and then we're going to convert this into a Boolean. It displays prettier when we actually call this function. And then, yeah, we're just going to return the subtask or list. So yeah, basically here we just have 3 initial base functions. That first creates a subtask table. Second allows us to insert a subtask into the subtask table. And this is a relation. This is like some sort of relationship with the tasks table. And then lastly, we can get all the subtasks in this table. So I guess a question for the audience is, what relationship is this here, but between the task and the subtask? Anyone have a guess? No. Okay. It's okay. So if you don't remember from lecture, basically here we have a task ID that references a, like within the subtask, we have a task ID that references each task. So that means that each task can have multiple subtasks. So this is going to be a one-to-many relationship between the task and the subtask, because this is the, like, this just references the task. And you can have like, it's not unique like a one-to-one, so it's a one-to-many. But yeah, so now that we have these 3 main functions, we're going to add some routes in our app.py to test them. So the first one we're going to do is just getting all the subtasks. So it's going to be so it's going to be subtasks, and then we're going to call this get all subtasks, and then in here we're just going to call db.all subtasks, and then we can just return this. So we're just going to return I'll just and then I'm going to add a documentation. So this is our first route. So I'm just gonna run the server to make sure this works. App.py. Oh, yikes. Okay, cool. So I'm going to go to Postman. Remember in Postman, for each assignment, you should create a new collection. So here I'm going to call it demo. This is demo 3, I think. And then I'm going to add a request. Actually, I'll just use this from demo 1 because they're the same, but I'll add on to here. So right now I'm going to get the task. We have no task. I'm going to create a task first. So I don't really have anything. I just took all my prelims. So let's pretend I didn't take my prelims. So that's the for my 3410 prelim. And then I'm going to create a subtask. So, oh, I did not create a function for creating a subtask. So I'm going to do that next, but we can just test the subtask, like, I guess, route, and then you can see that we have no subtasks, but the route successfully goes through. So you can see the 200K in this top right corner here. But yeah, does that kind of make sense to everyone, what we just did? We basically just created some functions on a db.py that inserts subtask into a subtask table. And then in our app.py, we actually create routes that we can use to interact with the database. So we can, in here, we can actually use the functions we created in here to make subtasks. But yeah. Okay, I'm going to move on then. So next we want to create a subtask. I'm going to do app.route. And then the route I'm going to do is task dot task/task ID, and then subtask. And then this is subtask, and in here we want to take the task ID. So okay. So in this function, we're going to first get the request data. So this very standard post request stuff. First, we're going to check if the task already exists, because if it does, we don't want to create a redundant task. Check if task exists. And then we're going to first do db.getTaskById, which takes this task ID. And then we already created a function for this last time that basically gets a task from the task table with this ID over here. And this is really important because we don't want to create a subtask for a task that doesn't exist, because that would be bad. So yeah, this basically checks if a task exists. And so if task is none, then we're going to return a failure response, because the task ID we provided up here is invalid. But if it does exist, we're going to continue creating a subtask. So here we're going to actually create the subtask. So we're going to use the function that we created in db.py, and we're going to use insert subtask because we're actually inserting into the subtask table. So we're going to do db insert subtask, and then we're going to take the information that we got from the JSON body or request body. So to do that, we're just going to get the description, and then you can see here that this is really nice because we wrote documentation for our function over here, and so it tells us what we need. So done can be false because we just created it, and our task ID is what we got up here in our parameter /route query parameter. And so, yeah, now we inserted a subtask into our subtask table, and then in here we return the ID of the subtask we just created. So we're going to set subtask ID to that ID we just created, and then we're going to first check if this. We're going to first get the subtask. Doing db.get ID, which we did not create yet. So that's what we're going to create next. Subtask is none. We're going to return if a subtask doesn't exist, basically that means our thing didn't successfully create. So and then otherwise, we're just going to return a success response. We got 201 because 201 means we created it. So yeah, before we test this, I made the mistake of not writing a get subtask by ID function in my db.py. So we're going to go do that. So in db.py, we're going to do def get subtask by ID. And here we're going to take in a subtask ID and just query our subtask table with this subtask ID. So this is going to be perfect. Okay, so basically we're just executing this command, and we're going to just then other ways we're going to return if a cursor did not return anything. So yeah, this is how we do that. And then back here, now we can successfully try to test our create task route. Also, I just realized that I have very bad SQL syntax. So you should always capitalize your SQL keywords. So if you do what I do, you will get points off. So I'm an example of bad programming. Don't be like me. But yeah. So in here, we're going to duplicate this. And then we're going to actually create a subtask. So we know once we get all tasks that we have a task ID 1. And so with task ID 1, we're going to pass in a body. I'll just say the description is and then yeah, you can see I successfully created a task ID, or not task ID, a subtask. So if I want to verify it, I can go to my get all subtasks, and you can see that this subtask appears in all the subtask table. Cool. So that's the bulk of this, what we need to do. But some other things we want to do is just get all subtasks for a specific task, and also be able to write a route for that. So in my db.py, the last thing I'm going to do is get subtask by task, and then going to task and a task type. Here, get To do that, we're going to, again, write another SQL command. We're going to select task, ID, and then task and task ID. And yeah, we're just going to, again, create a list and then append to that list. So for row in cursor, we're going to return, or not return, we're going to add it to so yeah, this is getting kind of repetitive, but again, we're going to pass in the same things. And then we're going to write a route that basically does this, because it's kind of inconvenient that every time we have to see a subtask, we have to get all subtasks for all tasks. So we're going to create a route. Route. And we're going to do tasks. And then to do that, we're just going to call get subtask by task. Before we do that, we want to also do error handling. So we want to check if the task first exists. So we're going to do db.get ID. And then if task return response. And then otherwise, that means our tasks do exist and that we can get a sub, like all the subtasks for it. So we're just going to return a success response. That list, and then yeah, this should work. So I'm going to go over here and I'm going to make another request. Just duplicate this one. And then this one is going to be a GET request. And then once we get it, we can see all the tasks. We're still tasked for task ID 1. So yeah. Also, you should name your Postman request. So. And yeah, make sure you save your Postman request too when you do the assignment. But I think that's all for today's demo. Does anyone have any questions? I can put this all up, so if you need to catch anything, you can catch it. Okay, cool. So if no one has any questions, that's it for today's demo. But just know that this is like this is like a very basic implementation of relational databases in like the server. You can also do like updates and deletes and stuff with the like subtasks, and you'll have to sort of figure that out on your own, but it's very similar to the demo. But yeah.